the Windows users, once you download the VNC viewer and installed, then you may get that on your, maybe if you open up your the Windows browser, then probably here in the C drive, maybe program, let's just start with the program files 86. See if there is a VNC. So there is no VNC. Back up and go to program files. VNC is somewhere installed. Where is it installed? Oh, here, real VNC. Then there is a VNC viewer. You can make a shortcut like this, okay? Or you can run from here, doesn't matter. So if you click on this, then you need to make sure that your Raspberry Pi should be connected to the same router. Okay, so you need to make sure the SSID that you have for your the laptop is the same as the one for your Raspberry Pi. That should both your laptop and Raspberry Pi are connected to the same router. Of course, if you have a static IP so that you can get from DNS server directly, then you don't need to worry about it. But right now we are working on and play with within the subnet, and we are relying on dynamic IP address. So it should be that dynamic IP address is recognized and identified by the router who assigned. I already set up here 192.168.1.184, but if you do not know that, then if you do not have that for some reason, you may change your router, for example. Then you can do, I believe here, file, then there's a new connection, so that you can create new connection. So why don't I go ahead, click this, and then it asks me to enter the password for the Raspberry Pi. And the username, I didn't change that, it's still Pi. And password, I didn't change it, still, it is a Raspberry Pi. So, and then trying to do here. Let me see if I typed it correctly. Yeah, that is the password that I defined at first. Now I have this. This is my Raspberry Pi. Okay. And let's go back to our, I had the sensor there. So CD sensor and LS. Then I have LED1 PY, right? If I want to see what we had, then LED1.py. I want to view it. View is similar to PI editor, but we do not change the content, but we can see as if we are in the PI editor. that is another way that then you can enjoy. So this is the one that we had the last time. We worked on PCM mode, right? PCM, the GPIO pinout mode. So I want to change this to, for example, LED 1.py to LED PCM.py. So that is a PCM mode. LS, then I can see both of those. I want to also copy that LED 1.py to LED board. Board GPIO pinout mode. So I'm going to modify that. If I do that, then I have two versions of LED. LED one is, I would say, that is the same as LED PCM. So LED board, that needs to be updated. I want to look at. I am also trying to show our blackboard course material. That's what we are going to work on today. And I think it is, this is course material, blackboard. So, yeah, we need to do, wiring, coding, and sensing. One of the exercise was this, right? This was done last week. This is a PCM mode, as you see here, PCM mode. What I will do with the same layout, same wiring systems. It's not really exact the same wire, or we can use the same wire, the exact same wire, but we need to change that to board. So I want to say ground goes to, we're talking about board, right? Ground goes to 246, pinout number 6, and then long leg of our LED goes to, for example, just right below 19, that's a 21. I believe we are talking about, we are using the same, the code, but different wiring. If we use a 21 for board, the pinout here. If you want to use the PCM, then the 21 here, the bottom. Okay. So that is it. So I'm going to push this into this LED board.py, and when I come here, then we need to change this to board, right? Or uppercase. Escape and hit Shift ZZ. Sorry, the D saved. If I see the difference between LED PCM and LED PCM.py, LED board.py, then only the difference here is the first one has PCM and second one has board. Okay, that is the command that you can, many times if you compare two files, then this command let you know that less than sign, which is the first file contains this line, and then greater than sign here. The second file contains the other. Because they are not the same, they are displayed here as the output of this diff command. So they are this much different. All the pin numbers remain the same. Therefore, we need to plug the pin differently. Okay. So shape and look. No. So this is the breadboard, and I have two cables. One cable here ground, and the other this goes to the pin. So long pin of this LED connected to that, and short leg goes to the resistance. Okay. And on my, let me show this. How does it do? Let me show this. Let's see. Okay. That's nice. I have other here. So this goes on top. Is it clear? That is this. Okay, so this one goes to the pin number. This is ground. The third ones from the right low, third pin of on the right pin rows. Okay, so I grab that here. And then if I refer to the textbook, and then the other pin number, that is for the power connection, that should be 21, number 21. So that goes here. There's no numbering, right? So 21. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. I believe that is 21. I need to make sure. Once more, I'm sure you can see it. Okay, so I'll count here. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. I think that is properly wired and connected. All right. And then back to right now that one, right? And I am coming back to my screen share. and this is the Raspberry Pi. What I'm going to do here is Python LED board.py. I am going to hit enter. So this is what I'm going to hit enter, and I am now switch my camera to that, so you may be able to see it when I hit enter here. So you can see lights on and off, on and off. Continually, right? So one PCM mode and one board mode. Okay, they are setting like that. What we will do, so I'm going to, how can we start? Stop. You can do in Control C, so that it will interrupt your current process, which is a Python execution. That is possible. To show that, what should I do? This is okay. To do that, if you see there, then you can see that. And there I can do Control C. So that is interrupted, right? So it is not doing anything right now. All right. As an example, we can extend a little further for this. What I would like to do is, I made here 1, 2, 3, 4. Yeah, 4 LEDs. So I am going to unplug this and move this away. Instead, this is what I made. Okay. Remember, we have 1, 2, 3, 4 LEDs. So each one wired exact the same as we did over there. Okay. Like only one LEDs. So in this case, we are going to use maybe 4 of those, and each each LED has a pinout from their long legs, and the short legs are grounded through resistance. Let's see. Yeah, they are grounded. So this is not really bad to we can figure this out. If you want that, we can do here. Let's go back to that LED. Let's see. My textbook somewhere. Do I have pin configuration? A little bigger. Not here. This is small, but if you remember that last time we when you had one single, then the ground, according to this board mode, it is the third pinout from the right pinout rows, and then we can use this ground also for those 4 LEDs. For each LEDs, if we're working on PCM, I want to see here GPIO 12, 16, 20, 21. 12, 16, 20, 21. Okay. 12, 16, 20, 21, which is at the bottom of the right rows, and then 3 pins backward, and then skip one and another one. In that way, they're all connected. So 12, 16, 20, 21. Okay. So stop sharing and go back here. If you see this, then I would say this goes to the third pin on the right end, and then in certain order, I want to put blue. Okay, let's do the orange first, or red. Red ones is the bottom. And after that, yellow next to it. And the blue, so again, third from the bottom, on the right. And then finally, blue, skip one and after that. So that is this. If I did a mistake, it goes like that, right? 3 in a row and 1 skip and another one. That is the order of this, in the same order of this LEDs. Okay. So right end I have red, and the yellow, green, and blue. So that is currently wired, and I am trying to show like this, so a little bit layered, that you can see. Okay. And if I show this clearly, it's like this. Okay. Okay. And then we need to do the code, right? So, what is the mode? Okay, now I need to go back to the screen share, and this textbook pushed away, and I have this. All right, so I want to copy again led1.py to led4 led4 bcm.py. So pi led4.pcm.py. So PCM is fine, and LED setup. We need to make 4 LEDs. So according to that, and there's a 12, 16, 20, 21. 12, 16, 20, 21. What that means is that if you come here, then I am going to use this 12, 16, 20, and 21. We are now working on PCM, right? And I plugged the wires into the 40, 38, 36, and 20, 32. So 32, 36, 38, and 40. The 3 in a row from the bottom, and skip 1 and then 3 again. That's what we did. So we use that pin number. So here in this case, it should be, I want to remove that 2 letters and insert into that 12 and hit escape button and move 1 and then XX to delete the 2 characters and insert and yeah, 16 and then 20, so I can change only 1 to 2, then I can press all button, all for replace, and number 2, simple. And then the other one is no, the 20, not 22. Should be all 20. So 16, 20, 20, 16, 20, 21. Right. And in the real code, it should be turn, what I want to do here, I want to turn on all and then turn off maybe in certain order, so we can do it. Delete that once by pressing double D for delta, DD, and then I want to paste it, uppercase P, 2, 3, 4, so I did that, 3 all. I want to turn it on from, say, 12, from red, and 16, and then 20. Turn on, and I am going to turn off again that order. Okay, so it'll be 12, 16, and 20, and then off. All right, that is, I believe that may work. And then hit escape button and then save it. And I am going to run it. Python LED 4 BCM.py to do that. So if you see the monitor here, I'm going to hit enter. Oh, they're all so quick. Looks like they all turn on and turn off. You know why? So we'll fix it. Because there is no interval between one LED to another LED when it turned off or on. So again here, I want to make a Control C to stop. It was a stop while it was on, that's fine. And come back to that editor again, more clearly. If you want to revise the same file that you did, then you can simply do exclamation. We call that bang. One bang and pi. Then it calls the command that we did, the recent past command that starts with the pi. So in this case, that's what I want to go back to the re-edit and modify the ones, right? So what I will do is set up fine, but when I turn it on, then I will do I want to make some interval, turn on and interval, turn on and interval, right? And then when it goes off, what I'm going to do is I'm going to leave it a little on. So let's say 6 seconds. And again, so what I did here, turn on the first LED and 2 seconds, second LED 2 seconds, third LED 2 seconds, fourth LED 2 seconds, fourth LED and then 6 seconds, and then turn off in the same order. And then finally, there's no. This is a preset somehow. I need to restart my Raspberry Pi. I think that is the easier way. Let's see another way that I could do. Yeah, I think if I would do it then. Let me see. Let's see. So that process is not on. Why that light is still on? Raspberry Pi is off. So this Python is still running. So Q -9 and 884 still runs. Still runs. All right. Best way is that I need to restart my Raspberry Pi. So log out and the reboot. Okay. I need to see. Currently, the Wi-Fi is not connected, so we need to do. Okay, that is connected. And come back to my Windows system. Yes, it is picked up. Very nice. So here, the terminal. Okay. ls cd sensor. And then I have Python LED for PC MPY. It's going this way. You don't see it yet. I need to. Oh, I think you can see it, right? all on, and then 60 seconds, and red it off that way. Yeah. So I'll interrupt that. If I interrupt, then it is still on. Wherever interrupted, it is interrupted right there. Okay. Next, here the screen. Here. So that is LED board. Okay, let's do distance sensor. I know some of you have already that. I want to. Okay, I'll show you what it is. That is distance sensor, distance measure, right? Distance measurement. So distance measurement needs some of the math calculation. The code from here to there, it's a little longer code. For in this case, we use board configuration, board mode. As you can see, particularly this sensor, HC. Okay, thank you. Okay. HC SR04. If you see this, then there are 4 pins: voltage, trigger, echo, and ground. So voltage, there's an input. You can send data there. Okay. And then ground. And then we use 2 pins in our coding, trigger and echo, so that we can check trigger and echo. So we say trigger pin number 7, echo pin number 11. And then trigger is to out pin, and echo is receiving the signal. So echo will receive reflected signal from the objects. That signal originally emitted from this trigger. So you have you need to set the time the signal is triggered, and then when signal comes back, then you need to set the time again. So you need to get the time elapsed between those 2 times, right? So a little bit of the wait time here, waiting for sensor to settle. So we give maybe 2 seconds for the sensor to get ready. And then trigger is out, GPIO output. This is a pin number. It's nothing but pin number, but we call it number 7. So we can sometimes put here number 7, or number 7 is assigned to another variable. This is more readable. Then you can say pin in trigger. And then power high. And then you need to wait maybe that short time period, and then you receive the time. And while pin echo, if there is no echo pin is activated, you need to that then you here time. Okay, when it was off, you set the time, and when it was on, then you need to set time. You need to measure the time. 2 time stamps. So first time stamps while this was 0, and when it comes to on, which means signal comes back. There is a reflected signal catch is received, which is here number 1. Then we need to take the timestamps. So once we have 2 timestamps, then we need to get the difference between those 2 timestamps. That is a round trip. So we need to see so pulse duration times that and distance will be okay. What it does is that pulse duration, the duration that we received, this is a time elapsed, times 17,150. This is the calculation that we looked at in the theory, right? This is because this is a sonic-based sensor, which is the voice, right? Yes, sound, speed of sound. Speed of sound is 340 meter per second, for example, right? So that is calculated. That's by a minute. So we need to convert that to the second, and convert that to the centimeter, not the meter. Then that is this formula, and then we will display that. That goes this is this is a code, and then we will wire like this and see how it goes. Okay, so I am going to unplug these things. That's already done. So I unplug them. Here, LS, we have that many. And then we need to make a BI, and then that is distance sensor. So distance.py, and open and import rpi.gpio as GPIO, and import. Time checking is very, very important in this particular sensing, because to measure the distance, signal needs to be triggered from my device, which means that is active sensor, right? And then we'll do try GPIO dot set mode, and then GPIO dot board. That's what we used, right? Because I counted right row and left row, and I get the power from the top one, which is pin number 2, and then 2, 4, 6. Pin number 6, that is a ground. And on left row, I used the two pins, 7 and 11. Okay, 7 for I think trigger, and 11 for echo. Okay, so to simplicity, I do not want to to save time, directly go to GPIO setup and pin trigger, which is a 7 instead of that setup, and pin number 11, that is for GPIO.in. What that means is that 7, that is a trigger pin, so a signal goes out, and 11, that is echo pin, signal comes in. And GPIO output currently 7, and GPIO low power. It's not high. It's not doing yet anything. And then we'll do a little bit of time delay. Okay, 2 minutes wait, and then we start trigger. So GPIO dot output, and then trigger 7 pin should be GPIO dot high, which means power is in that trigger. While GPIO dot input pin echo, which is 11, while we didn't receive anything, then we say pulse start time. We can simply say start time equals time dot time, while GPIO dot input 11, if it is while it is coming back, then we can say end time equals time dot time. We take the timestamps, and then we calculate. Duration is nothing but end time minus start time. Okay, and therefore distance is we round it up, so pulse duration, which is duration times 17150, round by 2, number 2. Okay, floating point place 2. And then we can finally print distance to the object is, we can say distance and then centimeter. Finally, GPIO dot cleanup. Okay, and save this. Hopefully there is no typo, no, nothing at all, then we may be able to see it. So Python and distance 7. Distance object 1 centimeter. We may try to do that continually if we do a while loop. Okay, so let's try to do the while loops. BI. And come back here, we can do while true. And it continues. Let's see what happens. Oh, we don't need to do all of this. We keep that here. Rather, we will do while true. Okay, let's see what happens. Sensor distance, it changes, right? When I move this, when I do this, the sensor is not really good enough. Let me see, do I have other sensors? This is sensor. I do not have. No. I think all out. not actively sensing continually. Only 2 times and then stop it. Let's see what happens. Logic-wise, so while loop, distance, let me get some print statement to see what happens. Print, I can see and trigger. But I think sensor doesn't get 1177, yeah. Pin echo 11. I think it looks fine. Oh, something missing, right? GPIO high, and then we need to do time slip 0.0001 0001, and then GPIO dot output pin trigger, which is a 7, and then GPIO W. Yeah, sending out and trigger and then stop. In that way, it can be doing. So we can get continually, right? If I change this, if I move my finger, then it'll be shorter, right? 26 or 20, 24 or 3 and 20. When I move my fingers, my palm away, then it goes up, and then I remove it, then it goes to the wall and come back. So that is a wall. And if I switch this to the other longer wall, yeah, 350, and the other, maybe we'll lose some of the, if it is very long, right? Right. So that is how this sensor is working. Ultrasonic. This is ultrasonic signals. Ultrasonic based distance sensor can make something okay measurement. It's not really accurate. If you want to make it accurate, then signal itself should be accurate. ultrasonic, if it goes longer, then because of sound system, our voice doesn't reach longer distance, right? You can hear only shorten distance, so it reaches only to that end. But if you use, for example, laser based sensor, we call LiDAR, then we will have really accurate measurement, and we can get the measurement of from the longer distance objects. That's what the police officers has equipped, and also some of the autonomous vehicles like Tesla has LiDAR sensors, so that car can measure the other cars very quickly, and then do some actions based upon that. Motion detection sensor. What else? Humidity and temperature. This I believe this is the one that I hold right now on my hand. This is infrared. I believe this is temperature sensor. It's not really contact temperature, but it can measure the body temperature, because body temperature emits some of the thermal signals, so that is received by this. So this is a passive. We're not going to do this longer and longer because you do not have also enough. Then here. So this is a motion detection. Okay, three pins out, as I said. So 3 pins. If you see here, then left one's signals. Signs is deep inside here. It says S, V, and G. So right end ones. Right end, this is ground, and left and this is a signal, and then in the middle there is a voltages. Okay, so we need to make it that way. And then here, what I'm going to do is I'm going to unplug all of this for our distance sensing. So this will out, and then this. I do not use the breadboard, and simply I'm going to plug this. Okay, according to the textbook, only I use is 3 pins out. So 3 pins goes into the Raspberry Pi. So we know power and ground, and then we're going to use board mode. So there's a numbering. So left one is say 11, which is left to the pin out number. So 1, 3, 5, 9, and 11. So that goes into here. So that is left ones, and then the power is number 2, and the ground is usually number 6. 2, 4, 6. Okay, that is it. And then there is a let's see. Oh, this is not. There is sensor. The level of sensing maybe over here. If you see here, let it down. And if you see here, that is orange. Hold it this way. The orange labels, so you can turn on and off, and that way sensitivity can be calibrated. So we'll see. If it doesn't work, then we can do it. Okay, so here I'm going to code it. So right now we have that many. So one more. What is a motion detection? So motion.py. I want to make it simple. Import rpi.gpio and sgpio. Time. Yeah, we need to do time, import time. And then GPIO dot set warnings. We don't need to do this, but sometimes we do. GPIO dot set mode. That is a GPIO dot board, uppercase, and GPIO dot setup 11. That is for signal, and then GPIO dot in. So we want to read it, and then GPIO dot setup 3. What are we going to do? 3. Oh, that is for LED to indicate whether there is a something detected. So let's forget about that, and then simply while true, I equals GPIO dot input pin number 11. If I is 0 is 1, then no intruders. We write it. Okay. If I is 0, then we can simply say print no intruder. No intruders, and then we can say that. Okay. We don't need to. Yeah, simply no intruder. n. Else if I equals 1, then print intruder detected. And then we can do time.sleep point to second. Oops. But the code is a little simpler than okay. So coding, the coding is done, and I'll save this. And I want to do Python motion.py, see what happens. Intruder detected. Something is very sensitive. Let's see. This is because of sensitive. Let me get some screwdriver to calibrate. Give me a sec. Let's see. I'm not sure which way it is calibrated. This is one end. That's prettier. Let's see. I want to put this a little above so that it cannot catch anything. I think it can because it has. Remember that it look at 180. I need to place this in. Let me see here. They were behind. So that means there is some input. I want to calibrate this backward to see if it is less sensitive. Let's see what we can do more effectively, code-wise. J equals 0 and Then we will do J equals J plus 1. I want to count if it really works. If the count goes up, it really works, right? And then I will do sleep maybe a little longer. So I continually see. One, three. Wait a minute. 1, 3, 5, 7, 9. Oh, it's a wrong pin. Yeah, it was plugged in the wrong pin. Yeah, now it works. No intrusion, no intrusion. And there is intrusion. I'm not sure if you can see. Where is the mode right now? Okay. Stop this and you can see that once the monitor while I am doing here. If my finger is there, then intrusion, and there's if I move this up, then no intrusion. If I do this, then there is intrusion, right? Like this. If I do this, intrusion. Moving up, no nothing. Okay. Yeah, a little bit of a mistake, careless wiring, then it doesn't receive the signals. That is the reason. Okay, I'll interrupt this, and then see what is. Finally, we will look at my mouse. Finally, we will look at humidity and temperature sensor. Okay, this one device can collect both humidity and sensor together, and then we'll look at PCM. And signals, we use GPIO 4, which is GPIO GCLK. And then power, pin number 4, or if it's PCM, then anyway, pin number 2 or 4. And then this ground, either this or here 34. That should work. Here in this case, we need to import this Adafruit underscore DHT. That should be downloaded. Set sensor type option DHT11, DHT12, or whatever that. But the one that we received here, depending upon your sensor, if it is a DHT11, then then adafruit underscore DHT dot DHT11. So we can use that. And then GPIO sensor is connected to BCM and so on and so forth. So code itself is not hard, but let's see, Adafruit DHT is available. Probably not, right? So anyway, we will try that. What we can do here is a DHT.py, okay? And then import DHT, and then sensor equals Adafruit DHT.DHT11, and then GPIO equal, we'll make that equal 4, and then humidity and temperature, and Adafruit DHT.read retry sensor.gpio. We're going to use pin number 4. And then if it's not none and temperature is not none, then we can do print temp equals 0.1F and Fahrenheit humidity equals 0.1F. Let's put that there. Format. Humidity, and then close one more. Else, failed to get I believe this is it. Save this. Python. Okay. The module not found. No module name Adafruit DHT. So we need to do. Let's see, PIP is available. PIP is available. So PIP cannot be downloaded.